All right, in this particular video, we're going to run a simulation from beginning to end. But before we do that, I want to look at one of the recipes for success. These things tell you step by step what you need to do. So the very first thing, it says read the entire problem and determine what it's being asked. It's going to ask you to identify the question, and I will do as well. What's the success? What do we want to happen? Component, what's going to be repeated? Identify a trial. How many successes are required till we know when to stop? Then we're going to have to determine how many trials we're going to run. And we'll either assign 1 or 2 digit numbers. And I said before, if the numbers let us divide by 10, we can use 1 digit. If they don't, we're stuck with 2 digit. We must address whether or not, whether we're going to skip any numbers or whether there are any numbers to ignore, because sometimes we won't use all of them. Address duplications. If percentages are used, duplicates are allowed. All right. Generally speaking, you can't choose the same person twice. So in that case, duplicates weren't allowed. All right. Explain how to run the simulation. Well, we're always going to begin from left to right. And we'll say, I'm going to use 1 digit, or if the case is, we'll run 2 digit until I have a certain number of successes. Then we're going to count how many 1 or 2 digit values that were not skipped, tell how many trials were run, and then we're going to say we're going to take an average. We will make a table of this. We'll keep track of it. We'll take the average as we said we would, and at the very end, we'll give our conclusion. Based on the simulation above, and we need to use the sentence stem, in the long run, on average, we would expect to have however many attempts in order to find our number of successes. We'd have to shoot 10 baskets in order to make 3, whatever the case is, whatever it is that we're repeating. So let's go ahead and put this in context of a real problem. So every Monday, a local radio station gives coupons away to 50 people who correctly answer a question. The coupons are numbered from 1 to 50, with the first person receiving coupon 1, the second person receiving coupon 2, and so on until all 50 coupons are given away. On Saturday, the radio station randomly draws numbers from 1 to 50 and awards cash prizes to the holders of the coupons with these numbers. Numbers continue to be drawn without replacement until the total number awarded first equals or exceeds $300. If selected, coupons 1 through 5 each have a cash value of $200. Coupons 6 through 20 each have a cash value of $100, and coupons 21 through 50 each have a cash value of $50. I'm going to pause right there and we're going to underline some stuff. All right. So we're going to continue until it equals or exceeds $300. So it may not be exactly $300, but if it's 280, it's not enough. 290 is not enough. 300 is. So is 305. So anything 300 or more, we can stop. It says coupons 1 through 5 have a cash value of 200. 6 through 20 have a cash value of 100. And 21 through 50 have a cash value of $50. Well, 21 is not divisible by 10 evenly, so we're going to have to use 2 digit numbers. But we only use 21 through 50. What about 51 to 99 and 00? I'm guessing those are going to have to be skips. It says run the simulation 3 times. And the question is, based on our simulation, how many winners are expected each week? Okay, so our question is simply, how many winners are expected each week? That was the very first thing, and they gave it to us. That was pretty nice of them. And usually they will. A success, well, a success is considered when we give $300 or more out. All right. Really, that's the end of a trial. So when we give money away is when it's a success. But in this case, we'll say that. A component, that's drawing the coupons. That's what we're going to repeat over and over again. We're going to run 3 trials. And in this case, duplicates are not allowed. First off, percents weren't there, but even if it's not a percent, duplicates might be allowed. But once we have a coupon winner, they don't get to win again because they said that we're drawing without replacement. because we're drawing without replacement, that key phrase without replacement means if it says without replacement, then they're not, duplicates are not allowed. The next thing we need to do is model it, which means we need to assign. And I will assign 01 to 05 as $200 winners. Well, I wasn't being very creative there. They just told me that 1 to 5, but I needed to make it 2-digit numbers. 06 to 20 is a $100 winner. 21 to 50 is a $50 winner, but then I have all those other numbers, 51 to 99 and 00 do not count. So how do I explain? I'm going to work from left to right, and I will select, in this case, 2-digit numbers until the payout amount is 300 or more, skipping any duplicates. We always have to address whether or not we're counting duplicates. I would then count the number of selected 2-digit numbers, which would be the number of prize winners for that trial. You could say I would just count the number of prize winners. That's fine. I will run 3 trials and take the average. Please make sure you tell me how many trials and that you're going to take the average at the end. So my random number table, and by the way, people always go, they recognize that on a calculator, the calculators really aren't random. There's a algorithm that puts it together. So how do they make true random tables? And those 10-sided dice that we used earlier is how they do that. So someone rolled, in this case, they rolled a 7, then they followed by 2, etc. But we're looking at 2-digit numbers. Our first 2-digit number is 72. Well, 72 is a skip. 74 is a skip. 91 is a skip. Hey, 33, that's in the $50 winner. So that's a $50 winner. Then 47 was a $50 winner. And 65, that's a skip. But then 03 is a $200 winner. 50 plus 50 is 100 plus 200. That totaled to 300. I needed to get to 300 to stop. So trial 1, I have 1, 2, 3 winners. When I go to trial 2, 91 is a skip, 63 is a skip, 83 is a skip, 65 is a skip, 66 is a skip. When we get to 42, well, 42 is a $50 winner. 70 is a skip, 93 is a skip, 37, oh, that's a $50 winner. 17, oh, that's a $100 winner. So that's 50, 50 is 100. Now we're at the 200, so we're not enough yet. Then we get to 59, that's a skip. 94 is a skip, 31 is 50. So now we're at 250, and then we got another $50 winner. Oh, excuse me, this is not a $50 winner. That is a mistake. That is a $100 winner. So 50 and 50 is 100. This is 200. This is 250. So we ended up that week handing out $350 because we didn't have a choice, because this was 100, 200, 250, and the next one made it 350. So that week we handed out 350, and we had 1, 2, 3, 4, 5 winners. All right, because 1, 2, 3 of them were 150, and 2 of them were $200 winners. The next one, hey, the first one's a winner, $50 and a $50 and a skip and a skip. And 38 would normally be a winner, but no repeats. So we can't have that repeat. So this is not a winner. That's why I highlighted it. 91 is a skip, 57 is a skip, 90 is a skip, 19 is a $100 winner. There's a $100 winner. That's 100, 200, 300. We have 4 winners here. All right, so week 3, we had 4 winners, and we paid out a total of $300. When I add those up, 3 plus 5 is 8, plus 4 is 12. I divided it by the number of trials, and I got 3. 12 divided by 3 is 4. So based on my simulation, I expect to have 4 winners. So based on our simulation, in the long run, on average, we would expect to draw 4 coupons a week in order to have to give away 300 or more dollars. Well, that's where that came from. Based on our simulation, in the long run, on average, we'd have to expect to, what was our component? Giving drawing coupons in order to find $300 worth of winners. So that's pretty much what we wrote. All righty. I hope that helps. Look forward to seeing you on the next one. We'll do another full on simulation in the next one as well. Thank you.